so I'm kind of taking them isolated so it makes it easier. While I'm thinking of it, on your next unit exam, up to maybe a quarter of the exam will be this stuff. So a quarter or a third, I kind of lose track, but it's significant. So take it seriously. The second part, you guys will do fine with too. The only difference in the second part is that some of the metals, they're all monoatomic, will actually then be in the B group. Some of the metals, or they'll be, remember, the 4A metals or 5A metals, or heaven forbid 6A metals, you're going to have to use a Roman numeral in their name only. Okay, we kind of talked about that. So there's actually two ways to handle this. I prefer the whole, which is probably newer. The Roman numeral, remember, in the name, indicates the charge. It doesn't indicate the crisscross part. It doesn't indicate how many you need. It's the charge. Okay? So again, this kind of just reminds you when you use Roman numerals and when you don't. Okay? And again, you kind of looked at this before, and just assume, I know, for instance, let's see if I have an example. I don't have a good example. Well, all of these here, even though you are atomic number 23, vanadium, even though I don't have two cationic forms of vanadium, assume that there are at least two, if not more. So I mentioned this, there's three columns here. The first column is the cation, how many electrons it's lost, right? And the last column you recognize is the name that we're going to use. That's the more new way to do it. The old-timey way, and sometimes I'll run into students who have learned this, and I have to get out my cheat sheet, but for instance, iron 2 is really, you can use the name ferrous. Again, it's kind of old-time. Iron 3 would be ferric. So ferric nitrate is iron 3 nitrate. Okay, so there's a cross-reference of those. So these are these metals, and these are these metals. Again, you know, I'm gonna use this last one. Okay, so I'm not gonna use that because I don't have to. So let's take a look. I'll do an example up here of one at the top and one at the bottom. So the next part, for example, let's look at D as in dog. The first part. So the component ions is Cu 2 plus, and it's cation. The metal, and then the non-metal is S, of course, 2 minus. Okay, you know the S 2 minus from the periodic table, but the charge of the copper you don't know because someone had to give it to you. Sometimes you're just like, how would I know that? Well, someone had to give it to you, or you need to deduce it from how many was needed in the neutral formula. So if I crisscross, how many coppers do I need? It's a trick question. One. And then I just need one sulfur. So this is an example where if you crisscross, you'll get 2 and 2. But remember that if you can reduce it, which we can, you're going to have to do that. So of course that means Cu1S1. All right, so what would the name of this be? What's the first name of it? Copper.
Sulfide?
Yeah, but we're not done with copper.
Copper 2.
It is copper 2. Why is it copper 2? You find it on the periodic table. Yeah, it's copper 2 because it's in the group B elements and it's not zinc, cadmium, or silver. Yep, copper 2, and I heard you say sulfide. Exactly. So let's do one at the bottom there. How about E as an elephant? So iron 3 oxide. So what is meant by iron 3? What does that look like? You guys are working yours, aren't they? It means iron plus 3, and oxide means O2 minus. I really, really cannot emphasize on a test, I would write the component ions, because then you know how to crisscross. Assuming when you write the component ions, do you see where you have to get the charge right? Otherwise you don't know how many you need of each. So how many irons do you need? 2. And how many oxygens do we need? 3. So go ahead and do that. We only need one more part.
Goodness gracious.